we need to find the values of C in the system x prime equal to A times x to make the origin an asymptotically stable node. Let's call this matrix A. So x prime in general equal to A times x. The origin is an asymptotically stable node if matrix A has negative real eigenvalues. So we want to compute the eigenvalues of this matrix A, and then we will check the conditions so that the eigenvalues are negative real. So let's do that. We compute the eigenvalues. The eigenvalues lambda will be solution of the characteristic equation A minus lambda I. Compute the determinant of that. In this case, 1 minus lambda C, 1 minus 3 minus lambda, 1 minus lambda minus 3 minus lambda minus C times 1 minus C. Lambda square plus 3 lambda minus 1 lambda and minus 3 minus C. Lambda square 2 lambda minus C plus 3. In this case you can compute delta. Yes, this we have B is even. We should recall this. So usually when you compute, say we have this C, so let me use other notation, or ax square bx C equal to 0, you compute delta b square minus 4ac. We want real roots, so this one we want greater than equal 0, so that the solution x1, x2 can be repeated are real. So x1, x2 will be minus b plus minus square root of delta over 2a. That is the formula you should know. In this case, we have b here is even, b equal 2. So instead of compute delta, you can compute delta prime. So in the case b is even. So b is even. Let me write b is 2 times b prime. Delta prime will then be b prime minus ac. So instead of you minus 4ac, you just minus ac. Then x1 2 minus b prime plus minus square root delta prime over a. We can just compute it explicitly. You will reduce it to which is why we have this formula. Yeah. So let's come back to the question we have. We are here. Determinants of this matrix is this one. So this is the characteristic polynomial. I do delta prime because I have even numbers here. 1 square minus ac, so minus 1 times minus that, so plus c plus 3. So c 1 plus c plus 3, c plus 4. We want to have real lambda, so this one need to be greater than equal 0 for real eigenvalues. So this means c plus 4 greater than equal to 0, C greater than equal to minus 4. So that is the first condition. We need real eigenvalues. But more than that, we need negative real, so that we have asymptotically stable node. Now we compute the eigenvalues lambda and make sure they are negative. Lambda 1, lambda 2, they can be repeated. Lambda 1 can be equal to lambda 2. Minus 1 plus minus square root of delta prime over a over 1. Minus 1 plus minus square root c plus 4. You want them to be negative. So these two numbers here can be the same though, if this one is 0. But if this one is non-zero, then we need to check the bigger one less than 0, so that the small one will be automatically less than 0. Then the bigger one can be minus 1 plus square root c plus 4 less than 0. This one gives us square root c plus 4 less than 1, c plus 4 less than 1, you square both sides, c less than 1 minus 4 less than minus 3. Yeah. So this one is our condition, so that both of the eigenvalues are negative. Negative eigenvalues. And together with this condition, we have, in order to have the origin is an asymptotically stable node, C needs to be greater than equal to minus 4 and less than minus 3. So this will be our final answers.